Today I will tell you about different types of galaxy. So first let's start with Spiral Galaxy. Spiral galaxies are the most recognizable galaxies in the universe. They have a bright center with long curved arms stretching outward like a cosmic pinwheel. Inside those arms are huge clouds of gas, dust, and young stars being born all the time. Our own galaxy, the Milky Way, is a spiral galaxy. These galaxies rotate slowly over millions of years, and their shape is held together by gravity. The spiral arms are not solid structures. They move more like traffic waves, where stars and gas drift through them over time. Because spiral galaxies contain so much material for star formation, they are often filled with bright blue stars and glowing nebulae. Barred spiral galaxy. Barred spiral galaxies look similar to normal spiral galaxies, but they have a straight bar of stars running through the center. The spiral arms begin at the ends of this bar instead of directly from the core. Astronomers believe the bar helps move gas inward toward the center, feeding star formation and sometimes even supermassive black holes. In fact, scientists now think the Milky Way itself is actually a barred spiral galaxy. These galaxies are extremely common across the universe, and some studies suggest the bar structure may appear as galaxies age and evolve over billions of years. Elliptical Galaxy. Elliptical galaxies are very different from spirals. Instead of having arms or detailed structures, they appear as smooth, glowing balls of stars. Some are nearly spherical, while others are stretched into long oval shapes. They contain very little gas and dust, which means new stars rarely form inside them. Most of their stars are old, giving these galaxies a more yellow or reddish appearance. Many elliptical galaxies are thought to form after giant galaxy collisions. When the spiral galaxies crash together, their organized structure can be destroyed, leaving behind a large elliptical system. Some of the biggest galaxies ever discovered belong to this category. Lenticular Galaxy. Lenticular galaxies sit somewhere between spiral and elliptical galaxies. They have a central bulge and a flat disk, like spirals, but they lack clear spiral arms. At first glance, they can look calm and lifeless compared to brighter spiral galaxies. Most of the gas needed for star formation has already disappeared, so these galaxies mainly contain older stars. Astronomers think many lenticular galaxies may once have been active spiral galaxies that slowly lost their gas through collisions. Irregular Galaxy. Irregular galaxies do not follow a clean shape at all. They can look twisted, chaotic, or scattered across space with no obvious structure. Many irregular galaxies are rich in gas and dust, which makes them active regions of star formation. Their strange appearance often comes from gravitational interactions with nearby galaxies. Some have been stretched or distorted by close encounters, while others may still be recovering from ancient collisions. The Large Magellanic Cloud and the Small Magellanic Cloud are famous examples visible from Earth's southern hemisphere. Dwarf Galaxy. Dwarf galaxies are much smaller than giant galaxies like the Milky Way. Some contain only a few billion stars, while large galaxies can contain hundreds of billions. Despite their small size, dwarf galaxies are incredibly important because they are thought to be the building blocks of larger galaxies. Many giant galaxies have grown over time by absorbing smaller dwarf galaxies through gravity. Some dwarfs orbit larger galaxies like satellites, and many are dominated by mysterious dark matter. Astronomers continue studying them closely because they may help explain how galaxies formed in the early universe. Ring Galaxy. Ring galaxies are rare and visually striking. They appear as bright rings of stars surrounding an emptier center. Most of them form after a smaller galaxy passes directly through a larger one. The collision sends powerful waves outward, compressing gas and triggering massive bursts of star formation in a circular shape. These galaxies can look almost unreal, but they are evidence of the violent interactions happening across the cosmos. One of the best-known examples is the Cartwheel Galaxy, which still shows the scars of an ancient galactic collision. Peculiar Galaxy. Peculiar galaxies are galaxies with unusual shapes or features that do not fit neatly into normal categories. Some have long tidal tails stretching across space, while others appear warped, bent, or tangled together with neighboring galaxies. In many cases, their strange appearance comes from powerful gravitational encounters. Astronomers often use these galaxies to study how galaxies evolve over time because they reveal what happens during mergers and close interactions. The universe may look calm from Earth, but peculiar galaxies remind us that space is constantly changing. Active galaxy. Active galaxies are galaxies with extremely energetic centers. At the core lies a supermassive black hole consuming enormous amounts of matter. As gas falls inward, it heats up and releases huge amounts of radiation, sometimes outshining the entire galaxy itself. Some active galaxies shoot gigantic jets of energy far into space at nearly the speed of light. These galaxies can produce radio waves, X-rays, and gamma rays strong enough to be detected from billions of light years away. They are among the brightest objects ever observed in the universe. Quasar Galaxy. Quasars are the most powerful type of active galaxy ever discovered. They appear almost like stars when viewed from Earth, but they are actually distant galactic cores fueled by feeding supermassive black holes. A single quasar can release more energy than hundreds of galaxies combined. Because their light travels across enormous cosmic distances, quasars also act like time machines for astronomers. Observing them allows scientists to study what the universe looked like billions of years ago. Starburst Galaxy. Starburst galaxies experience an intense period of star formation. Stars are created there at rates hundreds of times faster than in normal galaxies. These bursts are often triggered by galaxy collisions or close encounters that compress huge clouds of gas together. The process does not last forever. Eventually, the galaxy runs low on the material needed to create new stars, and the activity slows down. During their active phase, however, starburst galaxies become some of the brightest and most energetic regions in the universe. Seyfert Galaxy. Seyfert galaxies are a type of active galaxy with extremely bright centers powered by supermassive black holes. Unlike quasars, the rest of the galaxy can still be clearly seen around the glowing core. Large amounts of gas spiral inward toward the black hole, heating up and releasing powerful radiation across space. Some Seyfert galaxies shine strongly in infrared light, while others produce intense X-rays and radio waves. They are among the closest active galaxies to Earth, which makes them very important for studying how supermassive black holes behave inside ordinary-looking galaxies. Radio Galaxy. Radio galaxies are galaxies that release enormous amounts of radio wave energy into space. At their center is a supermassive black hole feeding on surrounding matter. As material falls inward, gigantic jets of charged particles are launched outward at nearly the speed of light. These jets can stretch for millions of light years, far beyond the visible galaxy itself. The radio waves produced by these galaxies are so powerful that radio telescopes can detect them from incredibly large distances.